Hey guys, welcome to the first webcast this week, the final two webcasts of the semester. Today we're going to be talking about the urinary system, and we're going to be focusing on the kidney here. So I've written down a few things here that I want to go over first before we get into our drawing. First off, the kidney has two main functions. The first is going to be to filter waste from the blood, and the second is to regulate blood volume and blood chemistry. And the way the kidney does this is by filters the waste from the blood, that is by urine production, and that's how it excretes the waste. So the mechanisms of urine production that the kidney uses are going to be filtration, which happens in the glomerular capillaries, which we're not going to focus on today. But that's where it pushes out water from the blood and other ions and such into the kidney. Then resorption, which is going to be that fluid being taken back up into the blood, and secretion, which is then going to be selective ions and such being allowed back into the kidney and the nephron in order to secrete those waste products. The structure that we're going to focus on here today is called the uriniferous tubule. And that's going to be created by, or composed of, the nephron and the collecting duct. There's going to be a couple different portions of this nephron here, and we'll go over that. I'm going to just hop right into this drawing. So the first part of the nephron is going to be the proximal convoluted tubule. I'll draw this just like here. And by this point, we already have filtrate running through the kidney. We're already going to have filtrate running through the kidney coming from those glomerular capillaries. And the purpose of the proximal tubule is then to resorb most of that fluid that's already coming into the kidney. So the kidney, or about 99% of the fluid that gets passed into the kidney initially gets resorbed back into the bloodstream. And what it does is then it leaves those the waste that's trying to leave. So that's going to be things like urea and uric acid and creatinine, which are all nitrogenous wastes. And it kind of uses this reverse selective process, where it pushes everything out into the kidney, all of that plasma, or most of the fluid of that plasma into the kidney, and then resorbs back everything that it wants, and then leaves the waste. So from there, from the proximal convoluted tubule, convoluted means having numerous overlapping coils or folds, or also intricate and complicated. So we have this looping around business going on. Tubule. And then that leads into the loop of Henle, or the nephron loop, is something that your book calls it. And this is not really quite drawn to scale. I'm going to scroll down here a little bit. This is a longer loop. That proximal convoluted tubule is going to be completely within the cortical region of the kidney, whereas this dives into the medullary region. So here we have the loop of Henle. And we're going to have this portion of it be the descending limb, and then this is going to be the ascending limb. And we can note here that the proximal convoluted tubule, we can take a step back here, is going to be made up of a cuboidal epithelium, So we try to refer back to this epithelial structure, or epithelial tissue on most of these things we've gone over. This is going to be cuboidal epithelium. And the descending limb of the loop of Henle is going to be simple squamous. Simple squamous. And this is also, the whole descending limb is then going to be the thin segment as well. The thin segment. And that's the simple squamous segment. When we get to the ascending limb here, we get a thicker portion. And this thicker portion is actually going to run into the next portion as well. We're not going to draw the whole next portion this thick. This is the thick segment, which is then again made back up of cuboidal epithelium. Cuboidal epithelium. That ascending loop is then going to run into the distal convoluted tubule, and we're still within the nephron here. We're still within the nephron, that first portion. So let's follow this over here and draw our distal convoluted tubule. Distal convoluted tubule, and we're going to have simple cuboidal epithelium here as well. Distal convoluted tubule. And here we're going to find some more resorption and secretion, but less than what we found here in the proximal convoluted tubule. So we're going to find most of our resorption here in the proximal convoluted tubule, and here we have a lot less. This is more the fine-tuning resorption and secretion. And again, we're at cuboidal epithelium. And that's going to finish up the nephron structure. So let's scroll down a little bit more here. So we have, let's find the right color I used. This whole portion here is the nephron. And then what that distal convoluted tubule runs into is the collecting duct. The collecting duct. So let's continue this over just a little bit. And here we have our collecting duct. And this is where, for the most part, the composition of the urine that we're going to create and we're going to excrete from our body. Collecting duct. Collecting duct. And these are going to run into the renal papilla, and those renal papilla are going to form minor calyces, or minor calyx, and that's going to be composed of many collecting ducts all coming together. And then we're going to run into our renal pelvis, which is going to collect up all the urine, and then into the ureter, which is going to run into the urinary bladder. So again, before we talked about the two main functions of the kidney. We talked about the mechanism of urine production, filtration, which we didn't really go over, but we talked about that it went over in the glomerular capillaries. Resorption and secretion, which happens mostly in the proximal convoluted tubules and the distal convoluted tubules. And then we talked about the different structures between in the urinary, or I'm sorry, the uriniferous tubule of the nephron and the collecting duct, shown right here. Thanks for watching, and talk to you guys here soon again.